Hi guys, today we're going to do Polynomials Day 14 notes. This is factoring special cases. So here are your I can statements, what you should be able to do by the end of the notes today, and also your usual meme. So we are going to focus on the perfect square trinomial shortcut. These are two shortcuts you have already learned before. You learned them when multiplying. Now we're going to look at them when factoring. If you have something as a perfect square on the beginning and the end, and you test that this middle term is 2 times your first times your second, that is a perfect square trinomial, and we're going to be able to write that. Our other shortcut that we had was dots. If you have a perfect square minus a perfect square, remember this stands for, I believe it's on the next page. Nope, I'll write it out for you. So difference, remember, means subtraction of two squares. So we've got two different perfect squares. What I mean by perfect squares is a number like 5 times 5 is 25. So 25 is a perfect square. And these are our two shortcuts that we're going to learn today. We did multiplying from this step to this way. So going this way would be using the multiplying version. When we go this way, that's when we're doing factoring. And remember, we talked about this when we did, again, multiplication. We use these shortcuts. So same thing up here, except for it's the opposite. It's written backwards. Going this way is going to be factoring. And going this way, we use the shortcut for multiplication. Or multiplying, right? So let's turn the page and look at some examples. So the first one we're going to do, again, is the perfect square trinomial. If you have a perfect square on the beginning and to the end, and the middle term checks out, then we know that is a perfect square trinomial. In this case, we know that x breaks down to be x times x. That makes x squared a perfect square. We also know that 36 is 6 times 6. That also makes it a perfect square. Because this middle term is negative, we're going to test this out as negative 6 times negative 6. That still gives us positive 36, and that is still a perfect square. Now, to test the middle term, we need to know 2 times a times b. Is that this? So we're doing one of these times 2. Does that equal to negative 12? So again, what we're asking is like x times negative 6 times 2. Is that equal to negative 12x? Yeah, if we do negative 6 times 2, that's negative 12. So we get negative 12x is equal to negative 12x. That is true, which means that this is a perfect square trinomial, which means our final answer would just be rewritten as x minus 6, all in parentheses, squared. And that would be our final answer. You may get to a point where you don't need to do this check out on paper, and I will not expect that every single time from you. But I'm going to do it for the purpose of these two problems here so you can see. So we have a trinomial. It is a quadratic trinomial. The first thing we want to test if they're both perfect squares and if our middle case tests true. So we've got x times x. That's how we know we get to x squared. And for 49, we know that that is 7 times 7. I know this time it's a positive 7 because of this plus here. And we're going to do the check. Our check is asking, is x times 7 times 2 the same thing as this middle term, which is 14x? We want to know if those are the same. And yes, we get 14x equals 14x, which is true. That means this is a perfect square trinomial, meaning we can use this shortcut. So x is our first term plus 7, so it's a positive 7, all to the power of 2. And that's it. And again, you might get to a point where you can do that check step in your head and you won't need to write it down. But that is our perfect square trinomial shortcut. We're now going to do the difference of two squares shortcut. So our dots, which is what we just wrote on the front, is difference of two squares. If we have a perfect square minus a perfect square, we can break it down to be 1 plus and 1 minus of those factors. So 9x squared, is there a number times itself or an expression times itself that equals 9x squared? Yes. That is 3x times 3x. Is there a number times itself that equals 49? Yes, we just saw that. That was 7 times 7. So there's no middle term to test here. We don't ever have a middle term. It's just a difference of two squares. That means one of our factors is going to be 3x plus 7, and the other factor is 3x minus 7. And again, the reasoning for having 1 plus and 1 minus is why our middle term cancels out. It doubles up in a perfect square trinomial. That's where we have two of them, and we have to test the middle. But here, we do not have that because if one's a plus and one's a minus, they cancel each other out. Let's try the last example on this page. We've got n, which we know is the same thing as doing n times n squared. Same thing as like x and x times x to be x squared. And is there a number times itself that equals 64? Well, yes, that's 8, right? 8 times 8. So both of these are perfect squares. There is subtraction in between, so we can use our difference of two squares shortcut. One's going to be n plus 8, and one's going to be n minus 8. And that's it. Difference our two squares are nicer because we don't have that middle term to check. All right. So if you need to, take a second, pause, and look over these examples. Otherwise, we're going to move to the last page. So now we have all of our examples together, and we're going to figure out what one we need to do. So if we see two perfect squares and it's not a trinomial, it can't be a perfect square trinomial. So let's see if this is a difference of two squares. So is there something times itself that equals 25x squared? Yes, that would be 5x times 5x. And we just saw with 64 that that is 8 times 8. So this is a dots. That means one of our answers is going to be 5x minus 8, and one of our answers is going to be 5x plus 8. Remember, it doesn't matter which one comes first. The plus could come first and then the minus. It does not matter. The order of multiplication is not important as long as you have the right terms in the right parentheses. All right, so that one was pretty nice. Let's look at the next one. So here, we don't have either of our standards. We don't have a perfect square and a perfect square, and we don't have a trinomial. So let's see maybe if there's a GCF we can factor out of everything. There is. These both have an x in common. That would leave us with x squared minus 9. Now, inside the parentheses is a dots. It is a difference of two squares. Because we know that x times x gives us x squared, and 3 times 3 gives us 9. So it says an extra x on the outside, but one of our parentheses is x plus 3, and one of our parentheses is x minus 3. All right, last two examples here. So this is a trinomial, so we're probably thinking it's a perfect square trinomial. Let's test if both the first and last things are perfect squares. And in this case, they are. If we have x times x gives us x squared, and we have 8 times 8 gives us 64. So this is our perfect square trinomial. If we want to check that middle term, we have to do x times 8 times 2. Does that give us 16x? Yes, it does. So now we would know that this is going to be x plus 8 all squared. So for the last one here, we first noticed that maybe there is a GCF that we can factor out of everything. There is a GCF of 4. So we can take a GCF of 4 out. That would leave us with x squared minus 6x plus 9. So now we can think about, is anything left over inside the parentheses a shortcut that we just learned? Are our perfect square trinomial or a difference of two squares? It is a trinomial, so maybe it's a perfect square trinomial. Is x times x x squared? Yes, just like in every other problem. And we have 3 times 3. Because this term is negative, it's really a negative 3 times negative 3 to get positive 9. To test our middle term, we're doing x times negative 3 times 2 to follow the pattern. That does give us negative 6x. So therefore, we know our answer is x minus 3 squared, and we have that 4 in the front because it was our GCF to begin with. All right, that concludes our day 14 notes. If you have any questions, remember you can always send me messages on Remind, and you are going to work on your day 14 homework now.